Gas turbine cycles are a kind of motor cycles. They are based on the same principle than steam turbine cycle. So we have fluid. This fluid is compressed. Then the temperature of this fluid is increased here with the combustion chamber or with the heat exchanger, and then the fluid at high pressure, high temperature is expanded in a turbine. The technical work provided by the fluid during this expansion is higher than the technical work that is required to compress the fluid in the compressor. So there's the remaining torque that can be used to work a kind of machine. We may find two main utilities for gas turbine cycles. Either we want to use the remaining torque for the motion of a kind of vehicle, or we can use it to run an alternator and for electricity production. There are many different kinds and varieties of gas turbine cycles. A few of them will be presented in this course. Here I will choose to start explaining the working principle of the, I would say, most basic gas turbine cycle. So in this cycle we have an open cycle where we have an inlet of a fresh fluid at low pressure, low temperature. This is ambient air. The ambient air is at ambient conditions, so atmospheric pressure and atmospheric temperature, and this ambient air will be compressed in a compressor. This is an adiabatic compression, so it tends to increase temperature and pressure. So the outlet of the compressor is at high pressure and also with a higher temperature. This hot pressurized air is then sent to a combustion chamber, and in this combustion chamber a fuel is injected, so of course at the same pressure than the compressed air, and then the fuel will burn in the air in the combustion chamber about at constant pressure, and it will increase the temperature and change also the chemical nature of the flow. So because of combustion, then it will not be air, it will be what we call smoke at the outlet of the combustion chamber, and also still at high pressure and at high temperature now, because the temperature due to combustion has been increased a lot. Then this high temperature gas will be expanded in the turbine until the atmospheric pressure, so the same pressure that's the one we have at the inlet, and then we have the exhaust for the smoke. The technical work that is provided here by the turbine is higher than the technical work received by the fluid in the compression. So if we take this example of machine, we have one single axis on which we have the turbine and the compressors attached on this axis. So from a technical point of view, the compressor will remove some of the torque that is provided on this axis by the turbine, and then the remaining torque can be used for any kind of machine. So we have given the example of an alternator, but it can be, for example, here a propeller. So a propeller, for example, for an airplane, and in that case, this machine would be a basic turbo propeller for an airplane. What are the specificities of this cycle, and especially the main differences we have with the steam turbine cycle that will cause different usage of this cycle. One of the first difference is here we have an open cycle. So it's a bit strange to call it a cycle if it's open, because cycle is supposed to mean something closed. But there are some kinds of gas turbine cycles that are closed, so that's why we always call it a cycle even though it is open. So that's one of the first difference. We take ambient air that is available almost everywhere at least in the atmosphere, and it rejects smoke. That's one of the big difference with the steam turbine cycle, for which we need to have a closed cycle. So it changes two things. One first thing is we don't need to have this element here, which would be the condenser in a steam turbine cycle that will allow to bring the outlet of the turbine to the state we have at the inlet of the compressor or of the pump, and so we have something less, so it's an easier cycle to produce. We have one less transformation and one less element, but also here we don't need to transport the mass of the fluid, because the ambient air is available anywhere. The only thing we need to transport is the fuel. So we will have a machine that is much lighter than steam turbine cycle. But one of the drawbacks we have also in this cycle is we need to use a fuel that is suitable for a combustion chamber, so for being injected at high pressure in this combustion chamber and burning inside the air that has been compressed. And not all kinds of fuel are available for this. We can use, if we have internal combustion, we can use only a liquid fuel, and so it's not possible, for example, to use biomass or any kind of solid fuel or coal for this kind of turbine cycle. Also, one other big difference is that the fluid that is encountering all this transformation remains in gaseous form all along the cycle, and that's the difference in the name. Here it's what we call a gas turbine cycle, but in the other kind of cycle we call it steam, because we are close to saturation, and we have phase change when it's heated in the vapor generator, and also when it's condensed. And one of the consequences is that here in this gas turbine cycle we need to compress a gas, while in the steam turbine cycle the compression was with the liquid. And the liquid is usually almost not compressible, so it means that the technical work required to compress a liquid is very small. But here in this case we want to compress a gas which is compressible, so we need non-negligible technical work. We need to provide a non-negligible technical work in order to compress this gas. So it will remove a big part of the technical work that is provided by the fluid to the turbine during the expansion. And one of the consequences that this kind of cycle has a lower efficiency, global cycle efficiency, than the efficiency we are able to reach for a steam turbine cycle. There are still a few more advantages on this cycle. One of them is that we can very easily change the power of the cycle just by changing the mass flow rate of fuel, and it's also very fast to start this kind of cycle. So for example, for electricity production, when we need to have fast change of electricity production, or if we have a peak of demand of electricity, it's quite handy to use this kind of cycle to adapt very fast the production to the demand. And so finally, with the fact that we don't need to transport the fluid, we have a very powerful but very light motor that can be used not only for electricity production, but also when we have big constraints in terms of weight or of size. And that's why this kind of cycles are used quite a lot for airplane propulsion, either with a turbo propulsion or with turbo reactions for the airplanes. And it can also be used for smaller size engines, for ship propellers, for example for the bulk propellers that are embedded with the propeller below the ship.